Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Brothers Chaiken and Seth's brother, Joel. Hello. We're here to hopefully show you how to approach SAT math questions and let alone maybe any math question. Here we have math question, sample question 15 from a pamphlet or a PDF that the SAT people gave out to help you practice for the digital math SAT, which will come into the United States in the winter of 2024. So this is question 15 of 16, and let us go. Please read it, stop, try it yourself, and restart the video. The density of a piece of wood is something, kilograms per cubic meter. Units probably are important. A sample of this type of wood is in the shape of a cube, okay, and has a mass of that, of kilograms, okay. To the nearest hundredth of a meter, what is the length of one edge of this sample? Wow, look how close all the answers are.
Yeah.
Wow, wait, so that means we have to use a small thing.
Yeah.
Okay? So, density or ratio questions. And you have to know what density is. I guess they don't really tell you what density is. You have to know the density and they give you the units of density. The units of density are kilograms per cubic meter. So this is mass. Yeah. We're letting the units do the thinking over volume cubic meters. This is important. So first you need to know what the definition of density is. So what do? You have to just sort of plug the numbers in, right? What is the length of one edge of the sample? You have to know that in a cube, the volume of a cube of side S is S cubed. Don't forget, this is a calculated question. Every question on this test is going to be a calculated question. In fact, they're going to give you the calculator on the computer because most people are going to take this test on a computer. So, do we just sort of put the numbers in and see what happens? 353, and then with the units are kilograms per cubic meter, is the mass, which is 345 kilograms, and now S cubed. And S cubed is in meters, right? Meters, yeah. S cubed is in meters. S is going to be in meters when we solve this thing. So, of course, it's a calculator question. Yeah. So, we could cross multiply, divide both sides, whatever. Different ways you could do this, but doesn't it seem like S cubed is equal to 345 divided by 353? Isn't that right? 345 divided by 353.
Yes.
Which is 0.9773. And that's in meters, right? That's in meters. Oh, wow. Oh, so that's good. Nice. That's nice. To the nearest hundredth of a meter. Oh, they're very nice. So the nearest hundredth of a meter. So that means to the nearest penny, right? To the nearest hundredth of a dollar means to the nearest penny, really, right? Mm. So isn't that 0.98? 0.98, because you round this up. If you have 97.
Wait, watch out for the cube.
Oh my God. Wait, you're right.
Yeah.
Oh.
Yeah, whoa. You have to take either two ways to approach it. One is to take the cube root.
Right.
The second is to try the choices and cube them and see what happens. Which is easier.
Wow. I don't know. It depends on the person. Oh my God! So I probably would have gotten this wrong.
Yep.
Oh, I hate this. Yeah. I hate these questions. Oh God. Yeah, they put you. They make you do all this work, and then you get distracted. Wow. You're right. Oh, well, anyway, the cube root of this, the cube root of 0.9773 is actually 0.992. 0.992. So if it's 0.992, then to the nearest penny, it's 0.99.
Yeah, you got it.
Wow. Now, how do people take a cube root on a calculator? Because it's not really on a
Well,
calculator.
I think you could do it. A calculator has an general exponential function. So you type in the number, and then you type the exponent operator.
Right.
Then you take, say, parenthesis 1, divide 3, close parenthesis.
Right. But some people may not remember that taking that x, the cube root of x, is equal to x to the 1/3.
Well, that is something that everybody's listening. Just something to remember if you want to get a good score, a top score in the SAT, is that x cube root of x equals x to the 1/3 power.
Some calculators do allow you to type in an x and then the radical sign and then the number. I'm not sure if it's not obvious on the TI-84 how to do that, but there may be an option in there which we're not knowledgeable about, where you can...
Now, what about the other way?
Wait, hold on. I think I used to have a calculator that had an option that looked like this. It looked like this. It was a button on the calculator, and if you push that, you may be able to put in x is 3, y is 27, and then you can get the cube root of 27. Wow. Mm-hmm. Oh, I feel so embarrassed. But math is really very humiliating. Wow, I got caught on that one. So the two types of questions you're going to get wrong in the SAT are the ones you really don't know how to do, and then the traps, and then the ones where you know what to do, but there's something in there that distracts you, and you don't do it the way you should. And so I call it tricks or traps. I fell into one. Yeah. Okay. Yeah. So, but you need to, before we talk about the way you're going to do it, first you have to know, what do you have to know about this thing? You really do have to know the definition of density. And you have to watch the units. You have to know how to cross multiply to solve this equation. And then, of course, you need to know how to take the cube root, which I am really embarrassed about. So, Seth, you think that your approach, so you're offering an alternate approach, was to try all three numbers?
Yeah. Oh, actually, try only two numbers.
Right, because when a number's greater than 1, you know that it can't be these.
Yeah. So one of the numbers less than 1. So what you do is you take, the two choices are very close to 1. They're all very close to 1, right? The first one is 1 minus 2/100.
Okay.
And the second is 1 minus 1/100. Now, take those two choices and cube each of them and see what the result is.
Oh, that way you don't have to know how to take the cube root of something.
Yeah. Because the point of taking a cube root is to find the number.
Yeah.
Which, when you cube it, you get the number you're taking the root of.
Right, because it's easier on a calculator to do 0.98 caret 3. People can do that. So 0.8.
Now, how would you do 0.98 caret 3 without a calculator?
Yeah, but people have a calculator, so that's a moot question.
Well, if people who have the readiness to combine a lot of math can do it really fast without a calculator.
So those numbers cubed are 0.94 and 0.99 cubed is 0.97.
Yeah. Well, gosh, wow. Well, 0.99 is 1 minus 100th.
Right.
0.97 is 1 minus 300th.
Okay.
So one
Seth's
minus
writing something, but we don't see it. So let him write it, and then we'll move to the board where we can see it.
1 minus 100th
Here it is.
cubed is approximately 1 minus 0.03. 1 minus 200th cubed is approximately 1 minus point. Come on, stupid thing. Point 0.06.
Yeah, but nobody's going to know that. How many people are going to know that?
Well, some people will. They've learned the binomial theorem and the extensions of it.
But
some people will have learned, how to, taking, some teachers would present this, how to expand out 1 minus x cubed.
Right, when x is small.
But you expand, is that a fair thing to expand in high school?
Maybe.
1 minus 3x plus 3x squared minus, come on, stupid type. Minus x cubed.
Yes, but this is a calculator test. You have a calculator staring you in the face. You're taking this computer.
But you also have a brain sitting there telling you how to solve problems.
True. That's right. So the more you use your brain, the faster.
So one approach is to the first approach, plug it into the calculator, peck away at the keys. Second approach is let your brain work on it.
Right. Yeah.
So we teach multiple approaches.
That's right.
Take your pick.
Yeah. Again, I really feel embarrassed that I didn't. I was going to answer it without taking the cube root.
Yeah.
Yeah. The only thing I could say, maybe one hope, is be real. I wasn't really that neat, okay? But the neater you are here, and notice I ran out of space. The neater you are here, maybe you would notice that you would see s cubed is equal to 0.977, and then you would look at this and you wouldn't rush to the answer.
Now, for the change in the weight of the sample, could you demonstrate how to apply the shopping formula? How would the shopping formula apply to this?
The shopping formula is a percent.
Yeah.
What? No, I don't. There's no. What?
So we have 353. How much percent is taken off to get 345?
Yeah, but that doesn't really naturally apply in this question. I mean, yeah.
Yes, it does. It gives the ratio of 345 to 353.
Yeah.
It's 1 minus. It's 1 minus about about 0.029.
Okay.
About 0.023.
That's in the weight.
Yeah, in the weight. The 345 is the weight.
Yeah. Right. Then you got to take the cube root of that, because what?
Okay, what is that you take the cube root of?
The 0.977.
Yeah. Now 0.977 is 1 minus what?
1 minus 0.03.
Yeah. Yeah.
Okay. So we
And
offer
notice you
some
take the
different approaches.
cube root of 1 minus 0.03. Well, that is 1 minus 0.01 approximately. You took the 0.03 and divided it by 3.
Right. Yeah.
So it's in fact the case that, this is something that people may learn in physics.
Yeah.
I'll put it under here. If you have, 1 minus p to I'll give this example.
So we need to give you some space. Hold on. We need to put some.
Okay, I'm not writing.
Yeah.
See, I'm writing it under question.
Right. Yeah, it's right underneath the word math question 15.
Yes, right underneath the word question.
Yeah. Right. Yeah.
1 minus p, the cube root of that. When p is small, that's approximately 1 minus p divided by 3.
Right, and you learned that in calculus. But right, and the really big concept here that's really math is really telling us, which we sort of know from life, is that when you have something and you make a really small change to it, you usually know how that really small change affects what you have.
Yes, but the question is dealing with this situation when the relationship between the change in length and the change in volume is cubic.
Right. No. That doesn't mean that when you have something in life and you change something, the effect is exactly the same as the change. Sometimes the effect is maybe 3 times the change or 4 times the change.
When it's a cubing.
Yeah, no, but in general, if you have something going on and there's a very small change in what you do, then let's say you're eating something and you make a very small change in your diet, then your overall effect will be affected very slightly. But we don't. But you may not know the relationship between the very small change and the very small change in the diet.
Yes, indeed.
Yeah.
So, but this question is a harder question because it forces you to distinguish.
Yeah.
Between different possibilities of how much that small change is.
Right. Yeah.
One approach, if you can't figure it out, one approach is to narrow the two choices down to the two where the change is less than 1, and then take a random guess. And then your chances of getting it right go up from 1 and 4 to 1 and 2.
Yeah. Well, first of all, it was a good observation to notice that this side length has to be greater than 1. No, it has to be less than 1. Has to be less than 1 because s cubed is less than 1. So s has to be. So these are the only two you need to try.
The idea there, imagine, the cube, compared to the first cube is heavier than the second cube. So the second cube is smaller, and therefore its length is shorter.
Right. Yeah, there are different ways.
You think the context of the problem leads you directly to that relationship, without you having to calculate it with math.
Yeah. Okay. I mean, I think we've looked at this problem multiple facets. For some reason, density questions always come up. People love density questions. Teachers love density questions. It's just a ratio. Densities. Don't be scared by the word density. It's just a ratio.
Ratio of what?
Ratio of mass over volume. Mass over volume. Yeah. Okay. I guess we're done with this one. Well then, please give us your comments, like us, dislike us, give us comments on our video, or email us at satmathquestionoftheday@gmail.com, and we will then email your math questions to us at SAT math question at gmail.com. And just very quickly, let's take a quick look at how they do it. Notice ratio, rates, proportional relationships, and units. There's all this stuff. They do it this way. Oh, they do X. Oh, that's very clever. They do X as the volume, right? And then
no, X is the volume ratio.
No, X is the volume.
Yeah, it's the X is the weight ratio, which is proportional to the volume ratio.
Yeah. Okay. Then the volume of the sample is this. Oh, they tell you the volume of the sample, then they want you to take the cube root of it.
Wait a minute. Let X represent.
Yeah, so they're back to this.
Why they say? Hold on, something's wrong here.
No, I don't. What's wrong?
Well, go up to. Show me the the top. There we are. So, let X represent the volume of the sample in cubic meters. Which sample? The small sample.
What's the problem?
Okay. Yeah. Okay.
There's no problem.
And then the relationship.
They go down here, taking the cube root. Now, where are they going to do that?
Yeah.
Where do they take the cube root?
There
it is. There it is.
Yeah.
Yeah.
Okay. Yeah, but so what they left out, a better. Hold on. Let's show it. Please put it back.
Where, to the top?
To the explanation, yeah.
To the real explanation.
Real explanation.
Here it is, Oh, wait, let's make it small. Now everyone can see the whole thing.
Okay. All right, so they did here was right.
Yeah.
They wrote this. They put the one square meter in the denominator on the left-hand side, and X square meter in the cubic meter.
Yeah.
One cubic meter in the denominator on the left-hand side, X cubic meter for equality of density. Okay.
Right.
And then what they did was they threw away the units.
Right.
When they, okay, so they gave X, the X here is not given in terms of units.
Right.
So really it's X cubic meter.
Yeah.
Okay.
But they put the unit back here. They put the unit and they did it. Yeah, they did everything right. Yeah, they did everything right.
Yeah. The line above it, they said X equals this pure ratio of numbers. And then underneath it, they wrote X equals that ratio cubic meters.
Right. Notice that here they don't tell you how to actually take the cube root. They don't actually say how to do that on a calculator. You need to know how to do that on a calculator. We discussed how to do that. You raise it to the 1/3 power. What I did is I just raised it to 0.33333333 a little faster on the calculator. And to the fourth root of X is, let's say, the fourth root of 25 is 25 caret 0.25, which is a quarter, right? So here the 20th root.
Yeah.
The 20th root of 85 is 85 up to the 1/20th, which is 0.05. Okay, so that's how you do raise something to a root. If you take a root of something, if you want to raise it to a power, you raise it.
This is reminding me of yesterday's video. We were discussing how point something really means something hundredths.
Yeah.
That you'd rather say point instead of point. It's better. It's better for accuracy instead of saying 0.01 to say 1/100th. However, However, when doing arithmetic, it's quicker to think in your mind in terms of how it's written with the points. So both of us talked about 0.01 and 0.03, but that was easier to think of because it's shorter rather than saying 1/100th or 3/100th.
Right. Okay, I think we are seriously done. Okay.
Seriously done.
Okay, everyone, have a great day. I will talk to you later. Be back. Oh, tomorrow? No, tomorrow's not Thursday. Tomorrow's only Wednesday. Okay, we'll see you tomorrow then. Take care. Bye.
Bye.